Hello students, in the last video lecture we have discussed about the electrovalent or ionic bonding. So what is ionic bonding, how ionic bonding is formed, and what are the conditions of formation of ionic bonding, what are the properties of ionic compounds, and different examples of ionic compounds. So today we are going to discuss the second part, that is covalent bonding. Covalent bonding. The chemical bond which is formed by the mutual sharing or equal sharing of valence electrons between two atoms. So, as per the definition, when two atoms share their electrons, valence electrons, and equal number of electrons are shared between them, then the bond form is called covalent bonding. In the last class, we have discussed ionic bond is formed by the complete transfer of valence electron from one atom to another atom. The atom which donates electrons becomes positively charged, other becomes negatively charged, and there will be attraction among them and the bond is formed. Such type of bond is called ionic bonding or electrovalent bonding. But here electrons are shared between the atoms. Suppose atom A, it shares one of its valence electron, and atom B also shares one of its valence electrons. Equal number of electrons are shared between two atoms. Now see, this A atom has shared one of its electrons, valence electrons, atom B also shared one electron, and the bond form is a single covalent bond. If atom A shares two of its valence electrons, atom B also shares two of its valence electrons, then a double bond is formed between A and B. Similarly, if atom A shares three of its valence electrons, atom B also shares three of its valence electrons, then the bond form is a triple bond. So a covalent bond can be a single bond, a double bond, or a triple bond. That means if two electrons are shared between two atoms, then a single bond is formed. If four valence electrons are shared between two atoms, a double bond is formed. And if six electrons are shared between two atoms, an equal number of electrons are shared, then a triple bond is formed. So, normally a covalent bond is formed between non-metals. Generally, non-metals, they form covalent bonds. Non-metals which are there in the right side of the periodic table, generally they form covalent bond. And it is formed between the atoms of same or different elements. So it may be formed between the atoms of same or different elements, similar or dissimilar elements. Unlike your ionic bonding, it is always formed between the atoms of different elements. That means ionic bond is always formed between different elements of the type A and B. However, covalent bond, it may be formed between the atoms of the similar element like A and A, may be formed between B and B, may be formed between A and B also. Let for example, hydrogen atoms of the same element, they form covalent bond. Oxygen and oxygen atoms of the same element, they form covalent bond. And these two, hydrogen and oxygen, combiningly they form water molecule, AB type. It is also covalent bond. So a covalent bond may be formed between the atoms of the similar elements like this, or may be formed between dissimilar elements. Let us take some examples. Formation of hydrogen molecule. As we all know, hydrogen, its atomic number is 1 and it contains only one electron in its outermost shell or valence shell, or it contains a single electron. And how many more electrons are required by this hydrogen atom? और कितना इलेक्ट्रॉन चाहिए इसका नियरेस्ट इनर्ट गैस होने के लिए? इनर्ट गैसेस क्या क्या है? हीलियम, नियन, आर्गन, क्रिप्टन, xenon and radon. Atomic number 2, 10, 18, 36, 54 and 86. Now atomic number 1, hydrogen, is closer to its nearest inert gas helium, which contains 2 electrons. So अब हाइड्रोजन को और एक इलेक्ट्रॉन चाहिए नियरेस्ट इनर्ट गैस होने के लिए. तब क्या होगा? ये हाइड्रोजन का एक वैलेंस इलेक्ट्रॉन था, दूसरे हाइड्रोजन एटम का एक वैलेंस इलेक्ट्रॉन था, दोनों आपस में इलेक्ट्रॉन क्या करेंगे? शेयर कर देंगे, एंड ए सिंगल कोवेलेंट बॉन्ड इज फॉर्म बिटवीन देम. Now this hydrogen has 2 electrons in its outermost shell, we can say, and this hydrogen atom has also surrounded by 2 electrons, nearest inert gas configuration of helium. Another example, suppose formation of oxygen molecule, O2 molecule. Now, what is the atomic number of oxygen? Oxygen atomic number is 8. If you look at the electronic configuration, it contains 6 valence electrons in its outermost shell. And this oxygen atom is nearest to the neon. Now, it will try to attain the configuration of neon, but 10 electrons, that means 2 more electrons are required. So, अब oxygen जो है, it has got 6 electrons in its valence shell. Another oxygen atom has also got 6 electrons around it in its valence shell. Now this oxygen needs 2 more electrons to become octet. This oxygen also needs 2 more electrons to become octet. So what will happen? They will share 2 of their valence electrons. Each of them shares 2 of its valence electron, and a double bond is formed. Now see, after formation of this bond, this oxygen atom has got 8 electrons around it, 1, 2, 4, 6 and 8. And this oxygen has also got 2, 4, 6 and 8. So double covalent bond is formed between oxygen atoms during the formation of oxygen molecule. Here methane is formed between carbon and hydrogen. These are 2 different atoms of 2 different elements. So carbon, its atomic number is 6. If you write the electronic configuration in this manner, then carbon has got 4 valence electrons and hydrogen has got only 1 valence electron. This hydrogen atom is closer to helium. It will try for 1 more electron in its outermost shell, and this carbon atom has got 6 electrons. That means it needs how much? 4 more electrons to become the nearest inert gas configuration. So this carbon, it has 4 valence electrons around it. Each hydrogen atom has 1 electron around it. So what will happen here? Each hydrogen atom shares its electrons with 1 valence electron of carbon, thereby forming 1 covalent bond between 1 hydrogen and carbon atom. In this manner, 4 covalent bonds are formed around carbon atoms. Of course, ये मीथेन का स्ट्रक्चर नहीं है. मीथेन का एक्चुअल स्ट्रक्चर है, it looks somewhat like this. This is called tetrahedral structure. Tetrahedral with bond angle 109 degree 28 minute. This is because the repulsion among these bond pairs of electrons, it should be same everywhere according to VSEPR theory, that is called valence shell electron pair repulsion theory, which is there in +2 syllabus. So it is not, it is beyond the scope of your syllabus. So anyway, just remember it has a tetrahedral shape and has bond angle 109 degree 28 minute. Coming over to another example. Five, formation of ammonia molecule, that is NH3. Again here nitrogen has atomic number 7 and got 5 valence electrons in its valence shell, whereas hydrogen has only 1 electron. Each hydrogen requires 1 more electron, while nitrogen requires 3 more electrons to become octet. So nitrogen has 1, 2, 3, 4 and 5 electrons. Each hydrogen atom has got 1 valence electron and covalent bonds are formed like this. Each hydrogen shares its electrons with 1 valence electron of nitrogen, thereby forming 3 covalent bonds. And the shape of ammonia, this is called the lone pair of electrons which has not taken part in bond formation, and these are bond pairs, and the shape is called pyramidal shape, or it is also called distorted tetrahedral shape, and this angle is 107 degree. Okay, so next example, let us see. Number 6, formation of water molecule H2O. Here oxygen atomic number is 8, electronic configuration 2 and 6. In the K cell we are having 2 electrons, in the L cell 6 electrons, which is the outermost cell or valence cell. So valence cell में 6 इलेक्ट्रॉन है, और कितना चाहिए इसको ऑक्टेट होने के लिए? 2 ही इलेक्ट्रॉन चाहिए. सो 2 इलेक्ट्रॉन ये शेयर करेगा. अब हाइड्रोजन एटॉमिक नंबर इज 1, contains only 1 electron, requires 1 more electron. So each hydrogen needs 1 more electron to become duplet. और ऑक्सीजन एटम जो है उसको 2 इलेक्ट्रॉन चाहिए ऑक्टेट होने के लिए. सो द बॉन्ड विल बी समवॉट लाइक दिस. अब मान लो कि ये ऑक्सीजन 2 2 4 2 6 वैलेंस इलेक्ट्रॉन्स है. अब एक हाइड्रोजन इधर आ गया और दूसरा हाइड्रोजन इज हियर एंड कोवलेंट बॉन्ड्स आर फॉर्म्ड. अब ये हाइड्रोजन का आफ्टर फॉर्मेशन ऑफ बॉन्ड कितना हो गया? 2 इलेक्ट्रॉन हो गया. अब आफ्टर फॉर्मेशन ऑफ बॉन्ड दिस हाइड्रोजन हैज आल्सो गॉट 2 इलेक्ट्रॉन्स, while oxygen has got 2, 4, 6 and 8. These are 2 lone pair of electrons. Of course, this is not the actual structure. The actual structure of water is somewhat like this, having 2 lone pair of electrons over oxygen, and the bond angle is 104.5 degree, and this shape is called V shape or bent shape. V shape or band shape. So note it down. Okay. So now come to the properties of covalent compounds. Properties of covalent compounds. So the properties of covalent compounds are almost opposite to those of the properties shown by ionic compounds or electrovalent compound. Last video lecture में जो मैंने पढ़ाया था कि ionic compounds का जो properties है उनसे just almost opposite होगा ये covalent compounds का properties. तो first properties is these may exist in all the 3 states of matter, that is solid, liquid and gaseous states. सो तीनों स्टेट्स में ये मैटर एग्जिस्ट करते हैं कोवलेंट कंपाउंड्स. लेकिन आयनिक कंपाउंड्स दे आर सॉलिड्स, दे एग्जिस्ट इन सॉलिड स्टेट्स. For example, here iodine, it is a solid which is covalent compound. Water is liquid, again it is a covalent compound. Oxygen, hydrogen, nitrogen, methane, ammonia, all these are exist in gaseous state. These exist in gaseous state. So these may exist in all the three states of matter. Secondly, generally these have low melting point and low boiling points. In case of ionic compounds, this was high melting and boiling points. Generally, these have low densities. In case of ionic compound, those have high density, and these are non-crystalline in nature. Normally, these are non-crystalline in nature. Again, these are generally soluble or insoluble in polar solvent like water, but are soluble in non-polar solvents like benzene, ether, carbon tetrachloride, etc. Generally, not all of course, exceptions are there. So, sixth, generally again, these are generally bad conductor of electricity. Again, here exceptions are there. For example, water, pure water, it is a bad conductor of electricity. It is a covalent compound. Whereas HCl, in its aqueous form, in its solution form, it conducts electricity. So exceptions are there. Generally, but however, generally these are bad conductor of electricity. Then again we can say these show isomerism. ये isomerism show करते हैं. Now what is isomerism? The compounds, the substances, molecules having same molecular formula which differ in their physical and chemical properties due to their structural difference, they are called isomers, and the phenomenon is called isomerism. For example, here is a covalent compound CH3CH2OH. It is called ethyl alcohol or ethanol, and it has molecular formula C2H6O. Another compound, suppose CH3O CH3 dimethyl ether, or methoxymethane. It is also the same molecular formula C2H6O, but they are different compounds, they have different properties, and hence these are called isomers of each other. So these are some of the properties of covalent compounds. Now, the next type of chemical bonding is called covalent coordinate bonding, or simply coordinate bonding. Coordinate bonding, or else it is also called dative bonding. Dative bonding. So now, as for the definition, the chemical bond which is formed by the partial sharing and partial donation of a lone pair of electrons between two atoms is called coordinate bonding or dative bonding. So here partial sharing and partial donation will occur. It is not complete donation like your ionic bonding. It is not a complete or mutual sharing like your covalent bonding, rather partial sharing and partial donation. That means here both the electron pairs belongs to one atom, but it is shared by both the atoms. Now suppose, what are the conditions? One of the atoms should have complete octet with at least one lone pair of electrons. The other atom should be in sort of a pair of electrons than the nearest inert gas, or it should have a vacant orbital. So now what happens? This lone pair of electrons over atom A is partially shared with the atom B, and the bond form is called coordinate bonding. Now the atom which donates its pair of electrons is called donor atom, and the atom which accepted it is called an acceptor atom, and this one is the lone pair of electrons, and this arrow is coordinate bond or dative bond. Now coordinate bond is represented by an arrow mark, the tail of which point towards the donor atom and the head point towards the acceptor atom. So here both the electrons belongs to one atom, but it is shared by both the atoms. Now see, in case of ionic bonding, look, in case of ionic bonding, complete transfer of electron takes place between two atoms. That means one electron donates electron, other atom accepts electrons. This type of bond is called ionic bonding or electrovalent bonding. In case of covalent bonding, equal number of electrons are shared between two atoms. Covalent bonding, electrons are shared equally between two atoms. But in case of coordinate bonding, partial sharing, that means both these electrons belongs to one atom, but it is shared by both the atoms. This type of bond is called coordinate bonding. Now had it been like this, अगर इसका एक इलेक्ट्रॉन और इसका एक इलेक्ट्रॉन शेयरिंग होता तो फिर कोवलेंट बन जाता ही, लेकिन दोनों इलेक्ट्रॉन एक का है और दोनों शेयर किया हुआ है. Such type of bonding is called coordinate bonding. Let us understand this one like this. मान लो कि एक लड़का उसका जो टिफिन बॉक्स एक लड़की को गिफ्ट कर देता है, डोनेट कर देता है. That is a complete donation. So the boy cannot get it back again. And we can compare this with ionic bonding. It is a complete donation. Now suppose एक लड़का और एक लड़की दोनों टिफिन बॉक्स लेके आए और दोनों शेयर करके खाए. सो इट इज इक्वल शेयरिंग, कोवलेंट बॉन्डिंग. लेकिन अगर लड़का अपना टिफिन बॉक्स लड़की के साथ शेयर कर रहा है, लड़की के साथ शेयर कर रहा है, तो द बॉक्स टोटली बिलोंग्स टू बॉय, बट इट इज शेयर्ड बाय बोथ. That type of bonding we can compare with this coordinate bonding. Okay, so now let us take an example and explain this. Suppose formation of ammonium ion. Ammonium ion formula NH4 plus. And this ammonium ion is formed by the combination of ammonia, NH3 and H plus ion. They form ammonium ion NH4 plus. Now look at the structure of ammonia. I have just now told you ammonia has a lone pair of electrons over nitrogen atom, and H plus ion has no electron. इसका एक इलेक्ट्रॉन था, एटॉमिक नंबर 1 है, और हम लोग निकाल दिए तो H प्लस आ गया. एक प्लस पॉजिटिव चार्ज मतलब एक इलेक्ट्रॉन माइनस हो गया है. सो इसके पास कोई इलेक्ट्रॉन नहीं है, दो चाहिए. ये दोनों इलेक्ट्रॉन इसके साथ अब क्या होगा, शेयरिंग हो जाएगा. सो आफ्टर शेयरिंग यू सी दिस नाइट्रोजन एटम हैज इट्स ओन इलेक्ट्रॉन 2, 4, 6 and 8, and this hydrogen has also got 2 electrons, and this bond formed between nitrogen and hydrogen ion is coordinate bonding, and that is represented by an arrow, overall positive charge. So second example, formation of SO2, sulfur dioxide. Now sulfur, its atomic number is 16. If you write electronic configuration in this manner, 2 electrons in the K cell, 8 electrons in the L cell, and the third cell it has got 6 electrons. That means it has 6 valence electrons. An oxygen atom has got 8 electrons, in the valence cell it has got again 6 electrons. So अब ये सल्फर को 2 इलेक्ट्रॉन चाहिए और हर ऑक्सीजन एटम को भी 2 इलेक्ट्रॉन चाहिए. तो यहाँ स्ट्रक्चर क्या होगा, ये वाला सल्फर it has got 6 electrons in its valence cell, 2, 4 and 6 like this. Now this oxygen, suppose in the left hand side it has got 6 electrons around it, and this oxygen atom requires 2 more electrons. So यहाँ क्या होगा, एक कोवलेंट बॉन्ड फॉर्मेशन हो जाएगा और एक ऑक्सीजन इधर है, लेकिन इसके साथ कोवलेंट बॉन्ड करने के बाद ऑक्सीजन का 2, 4, 6, 8 हो गया, और ये जो सल्फर था सेंटर में इसका भी 2, 4, 6, 8 हो गया है. अगर इसका 8 हो गया है तो फिर ये इलेक्ट्रॉन इसके साथ म्यूचुअल शेयरिंग नहीं कर पाएगा. क्या करेगा, इसको पार्शियल शेयरिंग करेगा और इसको ऐसे पार्शियल डोनेट कर देगा. तब क्या होगा, ये कोऑर्डिनेट बॉन्ड, और इसका जो इलेक्ट्रॉन 2, 4, 6, 8 और इसका इलेक्ट्रॉन भी वही 2, 4, 6 and 8 और इसका भी 8 बन जाता है. So in this way a coordinate bond is formed between sulfur and oxygen in SO2. In case of SO3, this electron is also partially shared. So in that case 2 covalent bonds, 2 coordinate bond will be formed. Now another example, suppose, okay, all right. Now next example is formation of, suppose, hydronium ion, H3O plus ion. It is formed by the combination of H2O and H plus ion. So we are getting here hydronium ion H3O plus. Again water, it has got 2 lone pair of electrons over oxygen, H plus के पास कोई electron नहीं है. Now what will happen, this lone pair, one of the lone pair of electrons will be partially shared with H plus ion and a coordinate bond is formed between them. So we get this one and overall positive charge, hydronium ion. Arrow mark of course. This arrow indicates a coordinate bond. Okay, thank you for watching.